that we have enough of when we order a display. We traditionally ship about 3 to 5% spare parts, but it's always good if your volume is going to be used for a long period of time to have some extra spares, especially if there's any potential physical damage as you're moving set pieces in and out of the volume. It's always good to have those extra spares. You know, the LED technology itself continues to evolve, but I wouldn't say it's much different in terms of speed than other technologies. So the cameras that you're buying and other electronics are probably going to be at the same lifetime as an LED display. You know, the pixel pitches are very narrow right now. As you can see, we got 0.4, 0.7 LED. So I would recommend that whatever your use case is for the space, that buy the best display that you could afford for the budget. And I think whatever that use case is, that it'll still be relevant for the lifetime of the product. As new technologies come out, it may be an option to purchase maybe a smaller display for close-ups or other things that could be used in addition to the existing volume that you have.
All right, Paul, your turn. So again, with these advancements in technology, how will advancements in bandwidth and processing speed for display help with productions going forward?
Great question. It's one of those things where as we continue to increase rendering, right, also bit depth, and we're also increasing resolution, that our problem in the back end becomes integration, right? There's a lot more hardware required. There's more time to set up. There's more complexity, and of course that results in more failure points as well, right, in the system. So as we move into say 5G or even 10G and beyond, this is going to allow us to have fewer cables, fewer items, fewer processors, keeping that ratio down to where it needs to be for a healthy, stable system. And also it's going to allow, although our systems make it more complex, they also are more simplified, which makes workflows easier and allows us to work harder to set them up and operate them.
So I'm going to stay with you on this next one, Paul. When you're planning infrastructure for LED volume installs, are there any rules of the road that should be adhered to?
I think the key thing is understanding what you need to do up front, right? Understanding the application, understanding the workflows. Are you working in an 8, 10, 12-week workflow? How are you planning on using the wall not only today, but is there a future purpose for it or expansion, right? So we can account for these things in the original design of the system. That will allow us to also pare down into, we have a very wide portfolio of products. So it's going to allow us to narrow that down into a few different options and then really allow the client and the other application to really determine the best fit for that solution.
Okay. Anything you guys would add?
Yeah, one of the things I want to add too, and I'd love to get feedback from the audience, over time, and as you guys use these volumes, we've kind of talked internally about the possibility of creating a way to upgrade the LED display, right? So the infrastructure that you have in place today, in terms of the mechanical structure, is really not going to change much. But does it make sense for us to start designing and developing products that allow us to swap out the modules or swap out some of the infrastructure on the back end, but keep some of the mechanical pieces in place? The LED technology is probably about 80% of the cost of or the LED modules would be about 80% of the cost of the overall LED system. But does it make sense to save on that 20%? I think that's something we would love to get feedback on as we get more involved into virtual production studios.
That's great. Paul, back to you. We've seen some companies invest in RGBW panels. How will this advance the market, and would you consider it cost prohibitive? Talk about the RGBW panels.
So, we're definitely currently playing around with it, I would say. We're looking into its capabilities and its performance advantages. At this point, like any new emerging technology or anything that's going to be very new on the forefront, it's going to be expensive, right? The supply chains have to be defined. We have to understand the suppliers. We have to win those suppliers. We have to understand exactly how are they going to perform over time. It's not just about the performance on day one, but is it going to have that long of a life cycle that we expect, that minimum of half-life of 100,000 hours, right? So as we went through all that, and then we marry that up with the pricing, that's really going to determine on what kind of impact it's going to have on the market. And of course, if the market and all these things are high, we've got to be providing products with the technology.
Yeah, sure. So at this moment, we only see like a single vendor supplying an LED in RGBW for an outdoor market, and to be honest, um, the other manufacturers of the LED should get into this market before one can actually start taking it seriously for a narrow pitch product. In addition to that, you really need an upgrade of the LED drivers, for example, to be able to drive not just R, G, B, but also W. Having said all of this, as Paul mentioned, we are fully in sort of in preparation for any technological advances that may came about as a result of these efforts. In the RGBW, we are monitoring and constantly talking to the LED manufacturers to see whether or not they actually have any plans for introducing these products in the narrow pitch product market.
And we'll open it up for questions to the audience here in a few minutes. So be thinking about those questions that you have for these guys. Nettie, you mentioned the LED manufacturers in the space. Why don't you guys talk a little bit about where you see standardization going as it relates to panel manufacturers and those that are involved in the production of LED?
Well, as right now, we're already engaged. We done some stuff with ETC and USC. They were also very, very prominent in the digital cinema rollout, moving from film to digital. They've already done some testing of our panels and trying to analyze and see what kind of standards can be created. But it is going to be quite a challenge because you really have to get buy-in from multiple manufacturers that are willing to also put their cards on the table and be able to drive through that. So we're doing our due diligence to make sure that our products perform, but getting a true standard is going to be a little bit more challenging over time until we start to get more players in the game.
So from my perspective, there's two categories of standardization. Ones that are created by the end users and those sort of community of end users, and then ones that artificially sort of addressed by the suppliers of the LED displays. I'm not really that optimistic about actually having the LED display manufacturers commit or agree on a particular standard that defines performance, for example. I've actually been through this myself a couple of different times without any success. To this date, I'm still educating people about the fact that HDR-ish is not a term. You either have HDR or you don't have HDR. So there's a lot of that in our industry still.
Yeah, and I think we spoke about this yesterday when we talked about bit rate for the displays. A lot of suppliers will advertise that they have 16-bit processing, but that's not actually at the display. We said it was about 8 to 10 bits at the actual display. So yeah, I think it's good to have standardization in the way we communicate the technology, but getting everybody to adopt to that is always a bit of a challenge.
Nettie, I'm going to come back to you. Talk a little bit about some of the latest developments in LED technology and how this will enhance production environments.
Right. Okay. So actually, this is very much in line to what we said earlier. LED technology is sort of being pushed in two different directions. One is in how we package those LEDs. We sort of addressed that yesterday a little bit, but also in the production of the LEDs themselves. As far as the production is concerned, which is going to be a bigger impact, we are now moving into the realms of micro LEDs, which are fabricated completely differently, and they actually produce a higher brightness efficiency, luminous efficiency, and also they actually are much smaller, so therefore they can achieve a sort of a narrower pitch as we go further in time. As far as the packaging is concerned, there's quite a bit of development. The latest packaging concepts are the wafer level chip scale packaging technology, which essentially puts the small dies, in most cases micro LEDs, on a piece of silicon or a CMOS, and the CMOS itself or the substrate that is used as a CMOS would have bumps in the back. So essentially it's sort of a flip chip, if you like. Eliminates the package itself as a body, and so therefore it's very small. It has a lot of better thermal performances, and it allows the current and existing SMD machines to be utilized as opposed to mass transfer equipments and so forth. So those are the directions that we see things are moving in the LED technology itself. How they impact us, of course, the technology of the micro LED will actually enhance resolution dramatically, but also brightness, which is a key ingredient for the XR business. And in addition, we would actually be able to achieve higher refresh rates, much higher refresh rates. Our current target for our immediate product is 480 hertz, for example.
Great. My last question before we open it up for Q&A, and this is a question we could probably spend hours on, but we'll summarize. So Nick, for you, if most manufacturers are utilizing virtually the same components, how does one display differ from the other?
So yeah, it's true. I think most LED companies do have access to a lot of the same suppliers. And internally, it comes down to the relationship that you have with them and what type of quality product you can get from that supplier. But the way that you really differentiate yourself as an LED supplier or as a manufacturer offering product into the market is one is on cost. The second is on your engineering capabilities. The third would be your production, including quality control. And then fourth would be the service and support of the team that's local and region. So for Unilumin, we are one of the, if not the largest LED supplier manufacturers in the world. So we have a huge price advantage in terms of cost. On our engineering side, we have well over 600 engineers that are actively working globally in order to design and develop products and get feedback from the market in order to for products and technologies that we work on. Production capabilities, I think we now have over 2 million square feet of manufacturing in a brand new facility, which gives us the ability to deliver very quickly. And then from our local team, I believe, and it's coming from the Unilumin point of view, we absolutely have some of the best people working for the company. Our team is made up of industry experts who come from the markets that you guys are all involved in. So we get the information firsthand. The skill set that we have in our engineering capabilities allow us to take those and turn them into new products probably faster than anybody else in the industry.
Nettie, Paul, anything you guys would add?
Yeah, so in complementary way, I would add to the way we actually approach product development is also very different. We tend to emphasize the big R as opposed to just R&D. There is quite a bit of investment in technologies that are 3 years, 4 years down the road, and there's sort of a built-in maturity in some of the stuff that we actually put out as opposed to, the usual stuff.
So let's open it up to questions from our audience. If you've got a question, get your hand up. We will find you with a microphone. Any questions for our panelists?
A couple questions you can answer, hopefully. You mentioned, Nettie, about passive to active. You didn't mention anything relative to timeline, or if you're a crystal baller, what type of vision would you see on that? That's one. You can answer them and I can pass the mic off. Second thing, does Unilumin publish fill factor? And or if not, do you have it available, the fill factor on your products? And is that a spec that will become more standard as the industry matures more? And third, any of the suppliers going to be US based in the next 5 years?
All right, so I'll take those in kind of a reverse order. So the last question was any suppliers doing the U.S. manufacturing. So yes, I think there are certain levels of manufacturing that's done by different suppliers today, competitors of ours as well as us, that can be done in the U.S. We are heavily investing in and looking at bringing more of that to the USA. And we hope that that's something that we'll be able to talk about in the very near future on timelines and exactly what that'll look like. But I do believe that will be a major game changer for Unilumin and a huge advantage for us to do manufacturing here. The second question was the fill factor. Yep. So fill factor is something that I was heavily involved in going back about 10 years ago in developing the concept of on what that looks like in terms of the physical size of the pixel pitch to the dead area of the PCB board. And we don't offer that as a spec today, but that is something that we could possibly publish as a white paper. We have so many different options in terms of LED packages and sizes for each one of our products. So it's not to say that our U panel S is this fill factor at this pitch. It also depends on what LED lamp that you're using for that. But I think that's something that's actually very interesting to get deeper into, and maybe in terms of a white paper to explain a little bit more about what fill ratio is and why you need to care about it.
So may I? So to also finish up what Nick was saying, the fill factor to us is what we call a black to light ratio. For the products that we're planning with the micro LEDs in the excess of 95%. And this is really important because you actually create a polymer black surface, and the only thing that the camera sees, in this case the camera or the eye, is the small micro LEDs inside. The differentiation between the pixel area versus the die area is what creates that 95% ratio, essentially. So to answer your other question, we are now working on specific custom projects that will deliver this technology with the active backplane fairly soon. But as to when that is going to be available for the general market, I can't answer that. Sorry.
Great questions. What other questions do we have? Raise your hand. We can find you with a microphone. All right, while you're thinking of your questions, we're here at Virtual Production Central. So yesterday we talked about Moray and the challenges that you could face with Moray. Why don't you guys talk about how you plan for and avoid Moray when it comes to LED?
Do you want me to? Or you? Okay. All right. Okay. So yesterday we talked about what actually causes the moray, and if you like, I can just briefly explain again. Moray is caused by any kind of it's very specific to camera lenses. When the camera lenses is focused on any kind of points of light, again, it doesn't have to be LEDs. It could be a garment, stripe lines or gridded lines, anything that its camera is focused on. As long as there's a disparity between light and blackness, the camera sees the moray. And what causes this is that the light is emitted from these points of light in a funnel shape. And when the light rays intersect, wherever they intersect, the amplitude of the light increases, and this is what the camera sees as the moray when it's focused on it. Now, it is true that the very first intersect is the strongest, and it fades as the additional lines of intersects are visible. Now, to alleviate this, there are ways to do this by adding a diffuser, but you have to be very careful because the diffuser has to be at the if you want to completely eliminate it, it has to be at or below the very first line of intersect, which means if in the case of very high pitch product, that distance is very, very small. There are a large number of issues concerning the fabrication of a display with the diffusers on it. But so before we get into that deeper, I would like to tell you also that it is also easier to actually ignore the moire as long as the pitch is very high. The very first intersect is very close to the surface of the display. Therefore, your camera may not see it. If it's focused on the talent, for example, and the display is further away from the talent, camera will never see it. The camera, in order to see it, it depends on two things. One is the actual the nature of the spectrum of this array of lights, and that depends on the packaging, the design of the packaging, and the shape of the LEDs. And the second thing is the pitch. So if the pitch is very high, even if it's a SMD package, which is the worst for moire, but even if the SMD package, if the pitch is high, your camera won't see it, depending on positioning of the talent and so forth. There are a number of improvements. For example, COBs, because they avoid the package, therefore they avoid the cavity that actually exaggerates the collimation of the light. They're better in performance for the moire than, let's say, SMDs. But it all depends on you and depends on how you specify. Yeah, also money. So all of that.
Yeah, one thing to add with regards to applications, there are currently you find where those ring zones are, that inner and that outer, and then the goal is to stay out of that area, right? It's normally how it's done today. So, as you move into type of pixel picture, to move that ring zone further out, obviously giving yourself more dynamic range to be able to work within. If you're in live presentations, usually there'll be markers or spiking of the floor, or even a rug or something that says, keep your talent in that zone, or don't go beyond that line. Or you'll have your cameras basically say, don't tighten up to this point, right? Stay out of that area, or soften up the back focus a little bit, and that will basically act as a photo diffuser to keep that ring from happening. So there are ways and tricks to work around it currently, but obviously we're also trying to combat that with our products that we're coming out to help either eliminate it or reduce that effect.
Yeah, and I think it's a really important topic, because I think the last thing anybody wants to do is to shoot a full day of content and then realize that after they go back and watch what they shot, that they have moire issues on the screen. So the last thing anybody wants to do is try to fix that in post.